So now, basically, they've been trying to move to a newer version of OpenGL, OpenGL 4, 4.5, but still the design of the API is still old, and it's limiting them to efficiently use the hardware. And one thing that is very important is that today everybody needs to use graphics and compute, because we have to compute a lot of things in real time, and we have to render them. And actually, some things that we compute will be applied to graphics as well, as we're going to see later. So because of that, also, the rendering quality that you see into your viewport, to your application viewport, is, I would say, pretty poor. And this is clearly a limitation, because what we want today into the viewport, we want to see the reality. We want to see, while we are designing at the earliest stage as possible, how what we are designing is going to be for real. Because the designer or the modeler needs to make sure that he's not going to do any mistake that when he sees the product for real will impact because he didn't see that how the edges of the part he was designing were, or because of some of the materials that he was applying, they have effects basically on the visuals that the product will look like. So you need to have realism inside the viewport of your application in real time. And I think this is now the next requirement for all the pro applications and the graphics engines. And last but not least, also it needs to make sure that it provides all the performance that you have in your hardware. Today's GPUs they can render billions of triangles per second. So you need to be able to take advantage of that and be able to display any kind of assembly into your application. So all those limitations, in fact, they prevent the content creation to have really a visual quality that is close to reality inside the application viewport. And so now the question is, how do we solve that? And this is what I'm going to mention to you guys. We are today, in fact, introducing Vulkan Easy. So Vulkan is basically the latest graphic API released by Kronos. It's a low-level API. And this is the next step for pro applications and graphic engines to move to this low-level API to be able, in fact, to take advantage of all the performance of the hardware and to be able to release all the performance and realism that you need into your viewport. So Vulkan Easy is basically an API that is on top of Vulkan to help all the applications and developers today so that they can easily move to Vulkan, to this low-level API. It brings all the benefits of this new platform. And basically, what is potentially low-level, so I would say difficult to put in place with Vulkan Easy, it's straightforward. And it's going to allow all the CAD applications, basically, where they need a lot of very specific features, for example, like line stipple, where they need to go through advanced features that they didn't really use very well in the past, like triangle culling, occlusion culling, that were designed to render very large assemblies. And now they can use them, and they can use them using multiple cores on your CPUs, and obviously on the GPU. The other part that is very important also is that with our GPUs today, we can do graphics and compute. We have what we call asynchronous compute. And so the fact that while you are doing your 3D graphics, we can compute at the same time, thanks to this API, we can do it very efficiently. at a very small granularity while we render a frame, basically. So here, basically a short demo of what we can do with a large assembly of about 25 million triangles that basically it's kind of a viewport of an application, and you can do all the different interactions that you do in a CAD application. And this is the kind of things, interaction and modification that you can do in real time, whatever size of data you can have, basically. Because the hardware performance is there. It's up to the application to have the right graphic engine in order to take advantage of this. And so we go through all the different modes, we show all the different details, and here the point is to have all the different parts and individually being able to modify them at any time. So this is the first step, unleash the performance and being able to interact with it. Now, the second point and the second introduction that we are making today is a new version of Radeon ProRender. Radeon ProRender is our GPU, CPU ray tracer that we released a year ago. And if you want more information about it, you can attend the session this afternoon, the rendering session, where we're going to go into more details about it. But we are bringing a new version with a new feature where basically, thanks to Vulkan, we can mix rendering. What does that mean? It means that we mix ray tracing and 3D at the same time. So you can now have the ray tracing and photorealistic quality inside your viewport and interact with it at any time. And this is what we mentioned at the beginning of the presentation. This is what we want. We want to be able, inside the application viewport, to have at any time the rendering quality and the photorealism and being able to modify and change things in real time. So this is basically what Radeon ProRender is going to allow. And just a quick video. In fact, what we mentioned, we are mixing the realism of ray tracing and rasterization thanks to the compute. We do the ray tracing, and at the same time, we do the 3D rasterization. And you can see into those videos, basically, the fact that we can interact with big assemblies, like an entire engine, in a photorealistic rendering, as well as any kind of parts where here on my left side, you see refraction. So basically, if you have parts, for example, with refraction, with very complex environments, reflections, you're going to see everything that will be physically correct while you are modeling at any time. And this is really what this technology is about, because the hardware that we have is ready to do that. And we, with the right software and the right graphics engines using ProRender today, people can benefit of that. And hopefully this will go through all your professional applications, and you will be able to see this and get the benefits. As we saw earlier today, real-time simulations, here we see real-time lighting, basically. So all the complexity of the lights, of the rays, of the refractions, the fact that you can see that we are simulating area lights, we are simulating really the light in real time, and to show that all your parts will be rendered physically correct while you are modeling, basically, so you don't get anything wrong, and you avoid any mistake while you you design your product. So finally, just to mention that if you guys are interested to win an Xbox One, you can visit our stand on the show. And well, I hope you will be interested to attend our session this afternoon so we can go into more details about rendering technology with ProRender and hybrid rendering. Thank you.